So welcome to our January 2022 Coffee Corner with Bentley Systems. This is our first STAAD Coffee Corner of this new year. Now, in case you're new to the program, Coffee Corners are complimentary sessions that are used to basically discuss specific topics or workflows using our Bentley products. Now today we're going to be discussing STAAD Advanced Concrete Design. You might have formerly known this product as STAAD RCDC or just plain RCDC. And before we begin, let's start by discussing what our goal is for today. Now obviously I can't include a full step-by-step procedure for designing concrete structures in STAAD Pro during a 1-hour session such as this one. So what I'm going to do today is I'm going to focus our attention on sending model data from an analyzed STAAD Pro model to STAAD Advanced Concrete Design. And we're going to cover various options that you can use to customize your reinforcement detailing. And the reason I want to focus on that process is because I think that is one of the biggest advantages that you can enjoy by using these products. Now, if you are interested in expanding on your knowledge on this workflow, we do offer step-by-step training for everything I'm going to be showing you today. And I'll go ahead and discuss where you can find those resources at the end of this session. So for today's session, we're going to be starting with a model that has already been created in STAAD Pro, so we can focus specifically on the design of the concrete systems. That being said, even though your model, or our model today, has already been created, I would like to just briefly discuss the overall workflow for STAAD Pro to create your model geometry and loading. So in STAAD Pro, you're able to create a model using either an analytical workflow or a physical modeling workflow. The analytical workflow is used to model your structure using analytical elements. The analytical model is a finite element model of the structure, which is typically processed directly by the analysis and design engine. If you are an experienced STAAD Pro user, everything before STAAD Pro Connect Edition, this would be the workflow that you're probably used to. In addition to that, new in STAAD Pro Connect Edition, we also allow a physical modeling workflow. This would be used to model your structure in the STAAD Pro Physical Modeler using physical members. The physical model is used to draw structural elements as they are physically constructed. The program will then decompose this into an analytical model, which is passed to the STAAD Pro Analysis and Design Engine when you run your model. Now today our focus is on designing concrete systems. So analyzing concrete structures for this workflow that we're going to be showing you today can either be created using an analytical workflow or a physical modeling workflow. They are both compatible with the STAAD Pro Advanced Concrete Design or RCDC. And you can use that product to design and detail. We're going to be focusing mostly on today your concrete beams and columns, but you can also use it to design your shear walls. Now for this session, we're going to be using a model that was created in the STAAD Pro Physical Modeler. Using this workflow, you would create all of your model geometry, loading, and analysis commands in the STAAD Pro Physical Modeler. You would then perform the analysis in the STAAD Pro Analytical Modeler and send your concrete systems to STAAD Advanced Concrete Design. If you were using the analytical modeling workflow, basically everything up until you get to the design concrete systems would be performed in the STAAD Pro Analytical Modeler. So let's go ahead and turn our attention to our STAAD Pro model. Now, as I mentioned earlier, I have already created this model geometry in the STAAD Pro Physical Modeler for today's session. I've actually already built the analytical model and performed the analysis, which I only did just to save a little bit of time during our session today. Just to give you a little bit of familiarity with the model that I've chosen for today's system, this is a concrete building system. You're going to notice that all of my concrete beams and columns were created using a physical member modeling approach. All of the material properties and parametric section properties have already been assigned in the STAAD Pro Physical Modeler. In addition to that, I am able to send my finite element mesh that represent my walls of my structure over to STAAD Advanced Concrete Design. These walls were created as surface elements in the STAAD Pro Physical Modeler. Finally, I've also created all of my loading, load case, load combinations, and analysis commands in the STAAD Pro Physical Modeler. So I'm at the point in my workflow where I'm ready to perform an analysis and then send data over for design and detailing to STAAD Advanced Concrete Design. So let's go ahead and review our analytical model. As you can see, all the information that I created in the STAAD Pro Physical Modeler has been correctly translated. Again, all of your material properties, including your concrete material properties and your section properties and plate thicknesses, have already been assigned. There's one important point that I would like to stress when using the STAAD Advanced Concrete Design for the design of concrete shear walls, and that is that your shear walls should be created using a parametric model. Now, when you use the STAAD Pro Physical Modeler, you can see that the parametric models will be automatically created for you. If you're using an analytical modeling workflow, then you're going to want to make sure that you model your finite element mesh to represent your walls using a parametric model. Now at this point in the workflow, I'm ready to go ahead and perform my analysis. And again, for the sake of time today, I've already performed the analysis, and we can see that that is current because I have access to the post processor in STAAD Pro. So after you perform your analysis, you're ready to start thinking about designing and detailing your concrete system. And what I want to do is I want to go ahead and send that geometry data over to STAAD Advanced Concrete Design. When you link your analysis program with your design program, such as STAAD Advanced Concrete Design, all of your member forces, reactions, load cases, load combinations, along with your section properties, will be available for import into the program. Now, what this link does is it goes ahead and links your concrete design detailing with your STAAD Pro model. You'll be able to save your detailing models from STAAD Advanced Concrete Design, and you can work on your workflow back and forth between STAAD Pro and STAAD Advanced Concrete Design as changes are made. So let's go ahead and access the Advanced Concrete Design. To do that, you're going to go to your workflow panel and click on Advanced Concrete Design. When you're sent over to the STAAD Advanced Concrete Design, what you're going to notice, let's take a look at my taskbar, my STAAD model isn't quite here. Whenever I close STAAD Advanced Concrete Design, it'll go ahead and send me right back to my STAAD Pro model. But what's important is you don't want to work in both of them at the same time, so it's basically locked me out of the STAAD Pro at this point. You can also see that it's automatically, when you launch this product from within STAAD Pro, linking you to your STAAD model. So let's go ahead and get started, and I'm going to call my first project my concrete columns. I can enter any client and any engineer name. Once I do that, I'm going to select my design code. For today's session, I will be using the ACI design standard. That's the US Concrete Design Code. And I have a couple different options for the different versions of this code available. Anything that has an M on it means that I would prefer to work in metric units. In addition to the ACI, in case I have any international users in here, we do have several other international codes. Now today I'm going to be focusing on the design particularly for my concrete columns and my concrete beams. And I'm going to be starting with my concrete columns. What the design element will do is it'll tell the program which elements to go ahead and import into this particular model, and you'll be able to save your different files as you work on them. So for example, I'm going to save a concrete column model, and then I'll also save one for my concrete beams. At this point, let's go ahead and create our project. Now basically what it's going to be doing is it's importing again all of your basic load cases, your load combinations, your resulting stresses and forces on your members. And again, all of your section property information. So the model has been imported, and we'll be able to see it on our screen. Let's go ahead and quickly, before we get started with anything else, I like to review some of the imported information. And I usually like to start with my column size information. Now here you can see all of the column sizes have automatically been entered from my STAAD Pro model. Now you do have an option to change your section properties once you get into your STAAD Advanced Concrete Design module, but you should note that with that type of workflow, you're going to make sure that you have to reanalyze in STAAD Pro and then come back here. I'm going to go ahead and keep all of the section properties that were specified in the STAAD Pro model. In addition to that, I'm also going to go ahead and take a look at the level data. You're going to notice that STAAD Pro has automatically detected where there are intermediate levels in my system. My system happens to be a 3-story structure. Each floor height is 12 feet. Now on this table, we're going to automatically populate your concrete and steel material properties. If this material property isn't quite appropriate for you, you can go ahead and select a different material property. If you selected a metric code, you're going to have metric options here. I selected an imperial code, so I'm going to go ahead and change this option to C4. That would be a 4,000 psi concrete mix. In addition to that, I'm going to go through my settings menu bar. Now I'm not going to go through every single item within these settings, but I do like to point out a few areas that you might be interested in. The first one is your design settings. Here you can tell the program what you would like your maximum capacity ratio to be and what types of design checks you want to perform. If you modeled your shear walls as members instead of using parametric models to create a finite element mesh, the program will use the length of the wall versus the thickness of the wall to either identify it as a concrete column or a concrete shear wall. I'm not going to change any of the default properties here, but this would be an important dialog for you to visit before starting your concrete design. In addition to that, since my focus on my session today is how to customize your reinforcement, it is important to visit your reinforcement settings. Here you can enter your minimum and maximum reinforcement ratios, and you can go ahead and tell the program which bars you want to be used as a candidate for optimizing your reinforcement steel. So if there's some particular bars, say like number 14s or number 18s, that you don't want used as candidates at all, you would unselect them here and they won't be used in the optimization process at all. You can also enter your minimum and maximum bar sizes that you're interested in and your tie types that you like. Again, I'm going to go ahead and keep all the default properties, but you can go ahead and view this to customize your optimization process. Now, if after you perform a design, you decide that you want to change the bars, you're not thrilled with the bars that came up, you can revisit this and then reperform the design. And then whatever changes you make will be used in your new optimization workflow. Now, one area you will definitely have to visit before performing a design is the loading information. Now, when your model is sent from STAAD Pro over to STAAD Advanced Concrete Design, all of your forces will be available in the members, but you will need to go ahead and tell the program what type of loads you're sending in, and then specify the load combinations you want to be using for the design. So let's start with our basic load cases. Now in here, what you're going to do is you're going to set your loading type. Now this will be especially important if you intend on having STAAD Advanced Concrete Design generate your load combinations for you. Once you've identified which primary load cases are important for your design, we'll go ahead and click OK. And then you can grab your load combination information. Now you can generate your load combinations directly in STAAD Advanced Concrete Design, or you can pull them in from your analysis file. Now my analysis file from STAAD Pro, I actually already generated my appropriate ACI load combinations that I want included for design. So I'm going to go ahead and grab those from my analysis model. If I didn't want to generate my load combinations in STAAD Pro, or whatever load combinations I have in my STAAD Pro model are not appropriate for the concrete design, again, I can generate them directly within STAAD Advanced Concrete. Now that I've defined my loads and load combinations, you're going to notice that now the design is available. The way I like to work in STAAD Advanced Concrete Design is I always like to perform a preliminary design just to see where I'm at so far. Once we do that, I'm going to show you a couple areas that you might be interested in that you can use to customize your reinforcement outcomes or your optimization process. So let's go ahead and perform a design. Now you can use either the icons or the menu bar, whatever your preference is. Now, as is the way the program is performing the design, is it's taking a look at each column at each level independently of any other location in the model. It is going to be considering the axial force and the moments on the members for each load combination. Based on the combination of forces, the members will be designed for axial compression and or tension and bending. So here I can see my results have been provided to me. Anything that says C wall would be concrete wall. Anything with just a C here with no combined wall information, that's just a column. Within here, this table, this output will be shown automatically for you after you perform a design. And I'll be able to see the section properties and material properties that were assigned. That's a good second check for me to make sure everything was designed accordingly. Now, as I take a look at these results, let's take a look at C1, for example. And what I'm going to notice is that I have different bars as I work my way up. Again, that initial design, since I didn't give it any other information, it's going to be designing each level of the structure for each column independently of the other areas of the structure. Now, if I like that approach, if I'm pretty happy with that, I can go ahead and modify the design for each individual column. To do that, you can click on the column that you're interested in, go to Modify, and you can go to Redesign section. What this will allow you to do, for example, is change your bar arrangement or any of your other properties. And here we have it. So when you go ahead and perform a redesign, what I'm doing is I am on the first floor for column C1. And you can see here what the bar arrangements are. If I correlate this with my main reinforcement table, I can see I have 4 number 6s. Those are these corner bars in yellow. And 12 number 5s are on the stories above. Now on this first floor, I have 8 number 5s around here. Now, let's say, for example, that instead of changing the bar sizes for this level, I wanted to maybe say I had 12 number 6 bars instead. In this window, I can go ahead and select the bar size I like, select the tool I'm interested in. This is a change bar diameter, and click on the group that I'm interested in changing. And we're going to notice that they're all yellow now, indicating 12 number 6 bars. If I like this approach, I can click Redesign. It's redesigning, coming up with new ratios. It checked this new reinforcement for the forces in that column. And again, I'm working on one column on one level. If I like everything, I can click Accept. And we're going to see it reflected in the output table. Now, that was the approach that I would use if I wanted to customize the reinforcement for one column at one level. What's important to note is that when you go ahead and click Modify Redesign Section like we just did, any new redesigns will go ahead and re-optimize the reinforcement. Now what I'd like to do, instead of taking a look at just one level and one column, this is where your options for grouping columns will become available. And again, that's probably the focus of what I wanted to go over today. So there are options where you can go ahead and group columns and you can group levels. If I grouped columns, what I'm basically saying is that all of the columns within this group have the same section properties and material properties, and I would like you to design them with the same reinforcement. This might make it easier for detailing and ordering of materials. I can go ahead and do that. In addition, I can also group levels in my model in STAAD Advanced Concrete Design. So maybe I want to say, well, I'm okay with each column individually being designed, but I would prefer, since I only have a 3-story structure, that we not change the bar sizes from one level to the next. So what I'm going to do is I'm going to focus on those different workflows that are available to you. Now, before you make any changes in STAAD Advanced Concrete Design, you want to unlock your design. So you can see here my design is performed. My design outputs on my screen. This little bar over here, all of them are green. That indicates everything was successful and passed the design process, basically meaning that an acceptable reinforcement scheme was determined. So what I'm going to do is I'm going to unlock my design. This is letting me know that the design is cleared and now changes can be made that will affect the design. So the first thing I'm going to do is I'm going to show you how to group your columns. Okay? Grouping your columns will ensure that the reinforcement is consistent between two similar columns. To use this workflow, you are going to want to make sure that the material properties and section properties are similar between the 2 or more columns that you choose to group together. Okay? To group your columns, we can go ahead and say Modify and Group Columns. What this will do is it'll show you all your columns in your model, and you can decide which ones you want to group together. For my particular model, it's super convenient because all of my column sizes are exactly the same size. So I'm just going to say group all of them. Okay? If you had columns where you had a bunch of different sizes and say some were round, some were square, you're going to want to just group the ones that are similar together, and you can create as many groups as you need. So once I am finished with this, let's go ahead and click Create. You can see all these columns have been grouped. Let's click OK. And I'm going to re-perform a design. Now my design output table looks much simpler because all of my columns have been given the same design. Now when you group your columns, basically what the program is going to do is it's still going to check all of your columns. It's still going to check the forces in each individual column. But the worst case, or the one with the highest critical stress ratio, will basically govern the reinforcement for the others. Now, if you noticed in my preliminary design, some of the columns needed 12 number 5s. On the first level, while some of them needed a little bit extra steel. So here we can see that that little bit of extra steel was now applied to all of them. Okay, but let's say, for example, now that I don't want to just group the columns in plan. I want to group them across the level. I would rather we not change the size of the reinforcement from level to level. And again, I just have a 3-story building, so for my building structure, I think that that approach would make sense. Okay? So again, let's unlock our design and make some changes. And what I'm going to do is I'm going to ask the program to group levels. So to do that, in the Level Data tab in this view window, we're going to just highlight the levels we want, right-click, and we could say Group Levels. When you do that, you're going to notice all of them are shaded in the same color instead of like every other. Okay, that's a visual cue that lets me know that these have been merged, or not merged, I shouldn't say that because that's something else, that these have been grouped together. Now, let's go ahead and perform a new design. So here you can see design output's even simpler because now my reinforcement is going from level 0 all the way up to 36 feet. That's the top of my particular structure, and we can see what governed. Now, doing this step-by-step approach I think is nice because then you can kind of see the full design process and feel comfortable with the results that you're getting. Now, one last thing I would like to mention, although I'm not going to do it for this particular model, is the idea of merging, okay? So let's just discuss that very quickly. When you send your model data over from STAAD Pro, what it's going to do is it's going to read in the intermediate beam levels as levels in the structure. But there are some times for certain buildings where you might have like small platforms or mezzanines or just some small lintel beams at that level. And in that case, you might want to consider that the floor-to-floor height should really be calculated across maybe more than one level at a time. For my particular structure, each story was at 12 feet high, and I had sufficient bracing. The effective length of the columns was correct as imported. Again, if I had kind of a weaker story that was not sufficiently bracing my columns, I could choose to merge that level to get a longer effective length in my column. And again, for that, you're just going to right click in this table and then tell the program you would like to merge. Now at this point, I'm pretty satisfied with my design and I can move on to review the rest of the information. If I wanted to create full working drawings of my reinforcement, I can go to reports and I have a couple different options. I can go to detailed drawings if I wanted basically some details of what I have created here, the detailing of my bars and the bending of the bars. I can view an elevation of both my walls and my columns, and I can also generate a bar bending schedule. Any of these would be created in basically a CAD format. They can be exported as a DXF and opened in either AutoCAD or MicroStation. In addition to that, you can also view your member forces if you wanted to see what your axial force, your torsion, your moment was at each individual column for each individual load case or combination. You can review that information in STAAD Advanced Concrete Design, and we also have a variety of reports that you can review that would be more in a text format. So here I can see my design calculations, a summary, and if I did have any red over here, that would indicate that I had a failure. I can go to failure diagnostics and that will give me more information. Now again, the focus for today's session is to go over how you can customize your reinforcement and the different options you have available to you in STAAD Advanced Concrete Design. So at this point, I would like to move our attention over to the concrete beams where I'm going to show you some similar options available there. Before I do that, I'm going to make sure I save my model so I can come back to it later if I want to. So I saved my project and I can exit STAAD Advanced Concrete Design. It will automatically save that project in the same directory that my STAAD Pro model is saved in. Upon exiting STAAD Advanced Concrete, it will send me right back to my STAAD Pro model that's still already analyzed, and I can move on with my workflow. So at this point, what I'm going to do is let's go ahead and take a look at those concrete beams. Now to do that, again, my model's already analyzed, so I'm just going to return to STAAD Advanced Concrete Design. Here I'm going to enter my project. I'm going to call this one concrete beams. I could enter my client and engineer information. And then I can enter my design code. Again, for today's session, I will be using the ACI 31814 with imperial units. Now you can see I'm still linked to that particular analysis file. But this time I'm going to go ahead and tell the program I want to work on beams. Now at this point I am going to make a decision about my detailing. Do I want to work on one level at a time, or if I have typical levels modeled in my STAAD Pro model, would I like to detail them all together? For my particular STAAD Pro model, my concrete beams, the section properties and everything at each level are basically the same. It's basically a typical level that's been repeated up the structure. So for me, for today's session, what I'd like to do is I would like to go ahead and group those beams across the levels. To do that, I'm going to go ahead and select the levels I'm interested in. This is my first floor, second floor, third floor. If my layouts on each floor were not similar, then of course I'd want to pick one at a time or just pick the ones that were similar. But we do have this option available, which I think will save you some time and your beam scheduling. It will still import all of the loads and reactions and section forces for all of the members or all of your concrete beams at the different levels of your structure, and basically be able to use all that information for one comprehensive design. So I'm going to go with that approach for today. It's still reading in the model. We'll just go ahead and give it a chance to complete this process. Okay, so the model data has been imported. These will be all of our concrete beams. Now I can see that the concrete beams for each level have been successfully imported, and I can see that level information in the design grouping area. It should also be noticed that continuous beams, whether you created your model in the STAAD Pro Analytical Modeler or the STAAD Pro Physical Modeler, will be automatically sent over and grouped together. So here, for example, let's go ahead and take a look at my imported data. I am hovering on Group 1. The program was able to successfully determine that this was a continuous beam area, which consisted of Beam 1, Beam 2, Beam 3, and Beam 4. It's similar for all the three different levels of your particular structure. What we're also going to notice is that the beam sizes have been successfully imported. Again, you wouldn't want to group among different levels if your beam sizes were different. If you wanted to take a look at your beam continuum information, you can go ahead and see that information as well. Just so you are familiar with the terminology we're using, the top line is the beam number that's used in STAAD Advanced Concrete Design, and it correlates to a beam number from my STAAD Pro model. Now, similar to the concrete column design workflow, I'm going to work my way through the settings menu. Now, I'm not going to necessarily hit every item within the settings menu for this session, but let's go ahead and take a look at the general and reinforcement information. This would be an important one that you're probably going to visit for every single model that you take a look at. Now, similar to your column design, you can go ahead and tell the program which type of bars that you want to be used as candidates for the optimization process. You can enter your minimum, maximum area of steel that's required, and you can go ahead and set up your minimum, maximum bars for each purpose throughout the length of your beam. In addition to that, for concrete beams, you would enter your material properties through this dialog. I'm again going to use 4,000 psi concrete. Now, if you had selected, again, a metric design code, you would have metric material properties here. And if the material property you're interested in isn't available, you can go ahead and click Add and create a new one for your purposes. Now, just like any model that is brought into STAAD Advanced Concrete Design, you're going to want to take a look at your loading information. So here, let's go to your Settings menu bar option. We'll go to our basic load cases and specify our load types. And in addition from that, you're going to want to take a look at your load combinations. If you generated your load combinations in your STAAD Pro model that would be appropriate for your concrete design, you can go ahead and import them. If your STAAD Pro model doesn't contain that information, you can generate those directly in STAAD Advanced Concrete Design. I'm going to go ahead and add my load combinations from my analysis model. Once you set up your load combinations and load cases, you are ready to perform your design. So let's go ahead and perform our design for this session. And I'm going to call this my preliminary design before I make any further customizations. I should be able to see the process of the design progress in the status bar at the bottom of my screen. The beam design is completed, and it's going to go ahead and point my attention towards the output. Now, in this preliminary design, I did already do a little bit of grouping. If you notice, when I imported my model, I grouped across levels, which basically means that a beam on level 1, 2, and 3, since those are the levels I selected, will have the same reinforcement. Now, the forces in those 3 different beams will always be considered in your design. But no other grouping was considered. Continuous beams were considered. No other grouping in plan was considered. So here we can go ahead and take a look at each group within our model. Now, if you'd like to customize your reinforcement on a beam by beam basis, you can select your beam group, go to your Modify menu bar option, and then we're going to go with Detail again. Now, you're going to notice a lot of these menu bar options are similar between the column module and the beam module, so hopefully it should become fairly familiar to you as you work your way through this product. Now, at the bottom of your screen, you're going to see your detailing information. Here we're going to see our top bars, bottom bars, and shear bars. If you would like to make any changes, so this is span 1, 2, 3, 4 for group 1. Okay. If you want to make any changes, you can double click on the reinforcement option. Here the program is going to remind me that I'm working on my top steel. I can change the quantity of bars in the end field and the diameter of the bars. If you are using a metric code, you're going to see your metric equivalent diameters here in this pull down menu. If you like your new bars, you can go ahead and click the Accept button and then close. And you can see here it's been updated here, and you can do that for any of the bar types, your top bars, your bottom bars, and also your shear bars. If you like any of the changes that you made, you can go ahead and click on the Accept button. It's going to recheck to make sure that is still good. Everything is good because this is still green over here. Now what that did was it basically changed. You can see the change has been reflected here. Actually this field. You can see that beam 1 in group 1 has been changed to 4 number 6s, top bars in the middle span of the beam. That's what those changes I just made. But what I'm noticing as I'm taking a look at this output table is that group 1, group 3, and group 5 are fairly similar. If I want to remind myself of that, I can always go back to my design input and take a look. So here I can see group 5 is highlighted, group 3 is highlighted, group 1. Each of these groups, my beam sizes are the same, my section properties are the same, and my span lengths are the same. So what I'm going to ask the program to do, instead of maybe modifying these on a one-by-one basis, what I'd like it to do is for group 1, 3, and 5, I would like it to detail those groups together. Since they're fairly similar and forces might be slightly different, but I would like the bar schedule to basically detail the same bars in each of these continuous beams. In addition to that, if I were taking a look, let's see, group 8, group 9, and group 10, I could probably get away with grouping these together as well. Now, as always, whenever you make any changes, you're going to unlock your design and then make those changes. So what I'm going to do is I'm going to go to my Modify menu, and I'm going to ask the program to group or ungroup some beams. What I'm going to say is group 1, group 3, and group 5 should be grouped together. I'm going to leave the default set to straight, but you do have the option if you had kind of a mirrored situation to select that. That's not the situation I have, so I'm going to leave it set to its default. So I've selected the 3 groups that are basically identical, and let's click on the Create button. Now those have been grouped together. It will consider the forces in all the different continuous beams, but it will go ahead and detail the reinforcement the same for whichever beam gave you the largest reinforcement. In addition to that, for this model, I'd like to group 8, 9, and 10. Create. So here I can create more than one group, as many as I need for my particular model. Let's click OK. You're going to see this table has been simplified. This is, again, an indication that we are grouping some members together. And now if I click on group 1, it'll highlight those 3. If I click on group 8, this is where I also perform this function, those are being grouped together as well. Let's go ahead and re-perform our design. And again, let's go ahead and just give it a moment to finish this operation so I can show you what the output looks like. Okay, the auto design is complete, and it's going to go ahead and send me automatically to the output. The output has been performed, and you're going to see that our table is condensed to reflect the grouping we just performed. Now at this point, that same command that I used earlier to modify the details is available, but now I'm going to be modifying the details for my group of my beams instead of just one individual continuous beam. So again, I can select whichever group I want. I can say modify, detail, and then it will allow me to customize the reinforcement for the group, the 3 continuous beams, and again at the 3 different levels. So this is a great way to go if you want to go ahead and start customizing your reinforcement to simplify your detailing and your schedules. And again, we can see all of that information reflected up here, reminding us which beams we have open right now. And the same option, double click on the reinforcement you want to change, and you can go ahead and make those changes. Now at this point, your beam design would be fairly finished. You have a lot of the same reports and drawings available for your concrete beams that you would for your concrete columns and shear walls. Those reports can be found in the reports menu. So you can come here, you can get some drawings. That would be your elevation and section. You can see your design calculations. This would be a text file. And if you had anything that was red over here, you're going to want to review your failure diagnostics report. This will let you know what exactly failed on which member in your model. In addition to that, we also have a bar bending schedule that we can generate. Again, this will be in CAD format, which could then be opened in either AutoCAD or MicroStation. And if you wanted to view your member forces, you can go ahead and view that information as well. At this point, we've completed our process for going through your basic design workflow using STAAD Advanced Concrete Design with a particular focus on detailing of your bars, or basically customizing the design process with your bar information. So I'm going to go ahead and save this file, and then I'm going to turn our attention to our question window and a few extra pieces of information that I would like to make you aware of. And again, as soon as you are finished, it's going to go ahead and dump you right back into your STAAD Pro model, and you can continue your workflow. If I wanted to revisit those files, I can go directly in STAAD Advanced Concrete Design and open them. Or I can access this workflow panel and open my previous models. You can go ahead and update both files as you work your way through your realistic, real-world workflow. Now, in addition to that, let's go ahead and wrap this up, and I'm going to try to hit some of the questions for today. So I want to thank everybody for coming to today's session on designing and detailing concrete structures in STAAD Advanced Concrete. Now, as I mentioned earlier, in a 1-hour session, I really had to focus what I wanted to discuss today, and I wanted to show you some of those grouping options so you can customize your reinforcement for your optimization process. Now, if you are very interested in using STAAD Advanced Concrete Design and would like to learn the software using more of a step-by-step approach, we do have some resources available for that. If you go to the Bentley Learn server, you'll be able to access all of our on-demand videos that we have available, as well as some dataset models and some step-by-step instructions that are basically in PDF format. We also have some collateral available on the Bentley YouTube channel for STAAD Advanced Concrete Design, the Bentley Structural YouTube channel, I should say, and we also have some wiki articles available on Bentley Communities. Now, for your convenience, I went ahead and put links to all those different pieces of collateral in the resource list. So I'll go ahead and encourage you to go ahead and access those resources. You might want to consider bookmarking them in your browser. And you may also want to consider subscribing or creating a sign-in or login for Bentley communities. Now that I've also directed your attention there, I also want to show you our Bentley Structural YouTube channel, and I would like to take an opportunity to go ahead and give you a brief tour of this environment. So if you go to YouTube and just search for Bentley Structural, you should be able to very quickly find our channel. This channel covers all of our RAM and STAAD products. Now, if in that resource list, if you didn't bookmark those in your browser, you can go ahead and access those from our YouTube channel. So here you can see I have a link to Bentley Communities, I have a link to the Bentley Learn server, and let's see, we have a link to Bentley Events. You can go to the events page to see future special interest group sessions or coffee corners that will be conducted. And then finally, if you have a detailed question, you can also access our technical support directly from our YouTube channel. Now, if you're interested in this type of content, I'm going to go ahead and encourage you to subscribe to our YouTube channel. The reason for that is because then you'll be made aware very quickly when we have new content available. If we were to take a look at some of this content, you can see that we have some tips and tricks available. We have some technical discussions or previous webinars available on demand. And we also have some very detailed training playlists for you to go ahead and walk your way through the workflows that we have available. We are continually adding new workflows and new playlists to this YouTube channel. So again, if you subscribe, you'll be notified very quickly when new content is available. In addition to that, I'm also trying to use this community tab to let you know when we have events coming up or new versions of our software available. Again, if you subscribe, you'll be able to see this information very quickly. You can see here that I advertised this session that we were in today on our community tab in our YouTube channel. Let's also discuss how often we do these coffee corner sessions. So we do perform a STAAD Coffee Corner typically once a month throughout each calendar year. We do take 2 hiatus months. So that's basically 10 free complimentary coffee corner sessions that you can expect each calendar year on STAAD for the United States. To sign up for future sessions, you're going to either go to the Bentley Events page, you're going to check your email, or again, you can go to this community tab on YouTube. We typically advertise when new events are coming up about a week before the session, which is when registration officially opens. Now, if I do have any international users in this room right now, we do have through the Bentley Events page coffee corner sessions or other webinars available in other regions of the world for STAAD. These might be for other time zones with colleagues of ours here at Bentley that are more familiar with international design standards too. So you might be interested in those. Again, you can go to the Bentley Events page for that. And to find the events page, I have a quick link on our YouTube channel. Now, that being said, let me go ahead and address some of these questions that I see. Again, I might not be able to get through every single question, but some of the ones that I can quickly answer, I'll go ahead and do that for. And again, the link to our technical support is also available right on our YouTube channel. So if anybody has a very specific question on a concrete project that you're working on now, that would be the best avenue to take. So let me go ahead and take a look at this. The first question is, which is a very good question, could special moment frames or special shear wall designs be handled in the Advanced Concrete Design module? To my knowledge, no, there is not any special reinforcement that is detailed in that particular module. We are detailing for the ACI 31814, not for any seismic provisions. So next question, if we modify the design and forget to unlock it, does this modification mean it will be disregarded? You actually are not permitted to make a modification when your design is currently locked, so you don't really have to worry about that. You won't be able to change any of your criteria, any of your loading or anything else while a current design is available, so you'll be reminded to go ahead and unlock your design. For the design of your shear walls, and so the next question is how to design your shear walls in RCDC. The first thing you're going to want to do is you're going to want to model your walls appropriately in STAAD Pro for that workflow. You're going to want to make sure that you model using parametric models. If you use a STAAD Pro physical modeler, that will be done automatically for you. If you use a STAAD Pro analytical modeler, you're going to want to make sure that you set it up using parametric models. You can apply any type of loading, including plate loads, to your finite element mesh, analyze your model, and then send it over to the RCDC, or STAAD Advanced Concrete Design. It's going to be designed in the same area that we used for our concrete columns. Now, it is important to note that there are some limitations currently with that particular workflow. Right now, we're only being able to take a look at walls that are of a uniform thickness, and we're not able to look at any openings within your wall. So if you have some complex wall geometry, perhaps another program might be maybe more beneficial for that type of thing, and including RAM elements might be a candidate for that. Someone asked a question, are the long-term deflections for the concrete beams calculated? Excellent question. Now, currently right now, STAAD Advanced Concrete Design, I'm not aware of any long-term or load history type deflections that are being taken care of. If that is important for your structure, I'm going to go ahead and recommend that you look into RAM Concept. RAM Concept can design concrete beam and slab systems, and they do a full load history analysis for deflections, which will include things like creep and shrinkage and so forth. So if that's a critical area for you, I'm going to go ahead and encourage you to take a look at that software. Okay, there was a question, when you model a shear wall parametrically, does the program consider that element as a solid element or as a plate element? You're basically going to create it as a plate element. So you can see here I've created some parametric models. The parametric models are transferred. These are plate tools, so they're transferred as a plate, not as a solid element. Okay, and the last question in the list, looks like we did get through all of them, is when will the ACI 31819 be incorporated? And for that, I would have to check with the development group. So if I get an answer on that, I'll be happy to post it maybe on Bentley Communities. I will go ahead and do, but right now, you're going to be able to use any of the codes that are available upon import. It's also important to note that not every workflow is available for each code. So if, for example, I select a particular code, I might see some of those radio buttons grayed out. That's because that code hasn't been applied to those types of elements as of yet. Okay, so keep your eye on that for any type of update, but whatever codes are available in the pull-down list when you import your model into STAAD Advanced Concrete will be available for your design process. So at this point, this looks like I've gotten to the end of the concrete-related questions. I want to thank everybody for coming to our session again. Again, please feel free to go ahead and look in your email, review the Bentley Structural YouTube channel and the Bentley events pages for upcoming sessions. We should be providing another session for STAAD in the United States on the third week of February. So we hope to see you then. I hope everybody is doing well on this Thursday afternoon. I hope everybody's healthy. And if you need anything else, please feel free to reach out to us. One of the best ways to do that is to go to the RAM and STAAD forum on Bentley Communities. So we hope to see you next month and have a good and healthy start to your 2022. Thank you very much.